Hello everyone, my name is Amit Chaulagai and today I'll be presenting my final project on designing an online store database system. In this presentation, I'll walk through all project overview, explain the database design before and after normalization, discuss the normalization process, review the SQL structure, and finish with real-world use case scenarios. So this project focuses on designing and implementing a relational database for an online store. The database supports core business operations such as managing customers, products, orders, payments, and shipping addresses. The main objective of this project was to create a fully normalized database, reduce redundancy, enforce referential integrity using primary and foreign keys, and translate real-world business requirement into structured SQL queries. I also created ER diagrams before and after normalization to clearly show how the design improves. This slide shows the ER diagram before normalization. At this stage, the database design is unstructured and inefficient. As you can see, multiple orders store multiple products using repeating columns like product ID 1, product ID 2, and so on. Customer and shipping addresses are stored as single text fields and product information is duplicated inside the orders table. This design violates first normal form and leads to redundancy, update anomalies, and data inconsistency. To summarize the issues here, the design contains repeating groups, non-atomic values, duplicated data. Because of these, updating product prices, deleting records, or inserting new data becomes error prone. This structure does not scale well and makes data integrity very difficult to maintain. To fix these issues, I applied the standard normalization process step by step. In first normal form, I removed repeating product groups and ensured that each field holds a single atomic value. This led to the creation of the order items table. In second normal form, I separated product details into products table and removed partial dependencies. In third normal form, I moved customer information, addresses, and payment data into separate tables and eliminated transitive dependencies. Foreign keys were added to enforce proper relationship between tables. Now this slide shows the ER diagram after normalization. The database is now clean, structured, and scalable. Each entity has a clear responsibility, data redundancy is minimized, and relationships are properly enforced using primary and foreign keys. This design improves performance, consistency, and long-term maintainability of the system. Now, this project includes SQL scripts for creating all major tables, including customers, address, orders, order items, payments, and products. Each table uses appropriate primary keys, foreign keys, and constraints to maintain entity integrity and referential integrity. This ensures that all data relationships remain accurate and reliable. So this is our SQL script for creation of table customer, where we have used customer ID as the primary key and their first name, last name, email, phone, created at. So we have created our current timestamp in created at so that the actual time is stamped in the database when the customer ID is created. So next is SQL script for creation of table address. We have used address ID as the primary key, and here we have used customer ID as the foreign key with reference to customer ID from customers table, and we have used update on update cascade and on delete cascade so that the update and delete in one main primary key main customers table can be applied automatically in the foreign key. So So here this is the SQL script for creation of table order items. We have the order items ID as the primary key, and line total is generated by multiplying quantity into unit price, and it is kept at virtual so that whenever it's uh, the command is given, this line total the attribute is generated. So we have foreign key as order ID and product ID. So similarly, here is the SQL script for creation of table orders. Here order ID is primary key. We have made the status pending as the default, and here foreign key and references it's done here, and here on delete no action, on delete no action, that means if the id wants, if there is the attempt to delete, there will be no effect. So similarly, in this slide we can see the SQL script for creation of payments, where payment id is the primary key and uh, payment date as the current time whenever the payment is made, the status is completed as default. So here's for the product. So now we move to the use case scenarios where our database can be used in real life situations. So the first use case answers the questions: what and when did the customer named Amit Chaulagai order, including quantities and price? This query joins customers, orders, order items, and products to provide a detailed transaction history for a specific customer. So this is the result that we obtain from that SQL query. The second use case calculates how much each customer spends on average per order. This helps the business understand customer value and spending behavior, which is useful for marketing and decision making. So this is the result that's obtained from that SQL query. Now the third use case identifies the top selling product based on total revenue, not just quantity sold. This allows the business to focus on high revenue products rather than only the high volume items. And here is the result obtained that is obtained from that SQL query. So the final use case displays all orders that are pending or not fully paid. It also shows how much payment is still outstanding and which customer the order belongs to. This is useful for tracking unpaid balances and improving cash flow management. And here is the final result from the final SQL query. So to conclude, this project demonstrates how normalization improves database structure, integrity, and scalability. By applying proper relational design principles, the system becomes easier to maintain and more efficient for real-world use. Thank you for listening, and I would be happy to answer any questions.